Mesh Network Survey. Wireless Mesh Network.
Wireless mesh networks (WMNs) are dynamically self-organized and self-configured, with the nodes in the network automatically establishing an ad hoc network and maintaining the mesh connectivity. WMNs are comprised of two types of nodes, which are mesh routers and mesh clients. This diagram shows the example of topology of a wireless mesh network.
The architecture of WMNs can be classified into three types. Infrastructure or backbones WMNs. This approach, also referred as infrastructure meshing, provides a backbone for conventional clients and enables integration of WMNs with existing wireless networks through gateway or bridge functionalities in mesh routers. Client WMNs provides peer-to-peer networks among client devices. A mesh router is not required for these types of networks. Hybrid WMNs, combination of infrastructure and client meshing. Mesh clients can access the network through mesh routers as well as directly meshing with other mesh clients. While the infrastructure provides connectivity to other networks, the routing capabilities of clients provide improved connectivity and coverage inside WMNs.
Layered communication protocol, physical layers. Some advanced physical layer techniques have been available for WMNs. Wireless radio of existing WMNs are able to support multiple transmission rate by a combination of different modulation and coding rate. With such modes, adaptive error resilience can be provided through link adaptation. Max layer. There exist difference between the MAC in WMS and the classical counterpart of wireless network. MAC for WMS is concerned with more than one hop communication. MAC is distributed need to be collaborated and work for multi-point to multi-point communication. Network self-organization is needed for better collaboration between neighboring node and node in multi-hop distance. Mobility is low but still affect the performance of MACs. A MAX protocol for WMNs can be designed to work on a single channel or multiple channels simultaneously.
Routing layer. Optimal routing protocol for WMNs must capture the following features: multiple performance metrics, scalability, robustness, and efficient routing with mesh infrastructure. Transport layer. To date, no transport protocol has been proposed specifically for WMNs. However, a large number of transport protocols are available for ad hoc networks. Reliable transport protocols can be further classified into two types: TCP variants and new transport protocols. TCP variants improve the performance of the classical TCPs by tackling down the following problems. The problems as stated. Application layer. Numerous applications supported by WMNs can be categorized into several classes.
Network management. First, mobility management. A distributed mobility management scheme is needed for WMNs. However, because of the existence of a backbone network, a distributed scheme for WMNs can be simpler than that for mobile ad hoc networks. Mobility management is closely related to multiple layers of network protocols, so developing multi-layer mobility management scheme is another interesting research topic. Power management. Power management aims to control connectivity, interference, spectrum, spatial reuse, and topology. Network monitoring. the statistic in the Management Information Base (MIB) of mesh nodes, especially mesh router, need to be reported to one or several servers in order to continuously monitor network performance.
Security. Similar to mobile ad hoc networks, WMNs still lack efficient and scalable security solutions because their security is more easily compromised due to several factors. The first one is their distributed network architecture. The second one is the vulnerability of channels and nodes in the shared wireless medium, and the last is the dynamic change of network topology. A widely accepted counterattack measure is authentication and authorization. For wireless LANs, this is taken care of by authentication, authorization, and accounting (AAA) services directly over the access point or via gateways.
And the results and analysis is mesh is a technology that's come from the optical networking world and has been adapted to the internet market. Mesh is a very smart way to provide resilient networks. Mesh architecture creates the opportunity to change data paths within a second when problems occur. Compared to the older solution for network resilience, mesh really was a big step forward. From the survey and discussion about wireless mesh network, we can conclude that the advantage and the disadvantages. As a conclusion, wireless mesh network is a mesh network created through the connections of wireless access through point installed at each network user's location. Each network user is also a provider forwarding data to the next node. The networking infrastructure is decentralized and simplified because each node needs only transmit as far as the next node. Wireless mesh networking could allow people living in remote areas and small business operating in rural neighborhoods to connect their networks together for affordable internet connections.